The meatloaf! I want it now! Oh. Hi. Don't mind me. I'm Andrew. Today I'd like to teach you how to find the intercepts and the asymptotes of the following rational function of 5 being divided by x plus 1 squared, and we're also going to sketch a little graph. So how do we do this? Just give me 2 minutes. 2 minutes. Okay. So what we're going to do is we're going to do the x-intercept first. And when you find the x-intercept of a function, all you're going to do is you're basically going to take the y value of that function or the function value, set it equal to 0. So when we have this function, you have r of x. Now, instead of writing r of x, just write y. That's going to be equal to 5 over then x plus 1, and that whole thing squared. So all you're going to do is, instead of writing y, just plug in a 0. And you're going to solve this for x. So you'd cross multiply here, but that would annihilate this whole term. So you'd have 0 is equal to 5, and then you're going to look at this like you're cross-eyed, because you're like, wait, 0 equals 5? Huh? That doesn't make any sense. What am I going to do from there? You're right, it doesn't make any sense. This is not a true statement, and basically what that means is that there is no x-intercept. It doesn't exist. Doesn't exist. So I'm going to write x-intercept, none. There are none. Okay? Then what you're going to do next is you're going to do your y-intercept. All right, so let's move this down. We're going to do our y-intercept. And same process, but instead of setting the y value equal to 0, all you're going to do is set your x value equal to 0. So everywhere you have an x, plug in a 0. And then just solve it. So there's going to be 5 over 1 squared, and obviously this is just 5. Okay? So the coordinate of the y-intercept is going to be x is equal to 0, and then y will be equal to 5. Cool. That takes care of that. Next, we're going to look at the asymptote. So let's do the vertical asymptote first. The first thing you're going to want to do is make sure you have your function in fully factored form, and then make sure, if it's applicable, you cancel any factors in the numerator and the denominator before you perform this process. Okay? In this problem, there is nothing to factor and cancel, so I'm just going to go about it. What you do after you do all that factoring and canceling, if necessary, you take that denominator, x plus 1 squared, and you set it equal to 0, and all you're simply going to do is solve it for x. So to solve this for x, we can take the square root of both sides because I got to get rid of the square. So that's just x plus 1 is equal to 0. And then you subtract 1 from both sides, and you realize that x is going to be equal to negative 1. And that is the value, that is the equation of the line for the vertical asymptote. Okay? Next, then, you're going to do the horizontal asymptote slash the slant asymptote. Now, when you do this, you're going to have one or the other, basically. Okay? And you identify whether you have a horizontal asymptote or a slant asymptote by identifying, if I could speak, that'd be nice, whether you have what's called a top-heavy function, an equal-heavy function, or a bottom-heavy function. And the way we identify this is by simply locating the values of x in the numerator and the denominator and seeing what side has the higher power. In the denominator, it is an x squared. I know it's an x here, but remember, you're squaring this polynomial. So therefore, it would be x squared plus 2x plus 1. So the highest power of x really is a square, is the 2 in the denominator. And there is no power of x in the numerator, and therefore you have a bottom-heavy function. A top-heavy function would have something like x cubed in this case. That would have been higher than the x squared. All right, and equal, obviously, is 2 and 2. Now, for a bottom-heavy function, you could just memorize this. It's really easy. That the horizontal asymptote will always be equal to, or the horizontal asymptote is always has a value of y equaling 0. Always. All right? And also what I said was top had a slant asymptote, and this has an equally heavy asymptote, but it's horizontal. But the method would be a little different. All right? Check out some more of the examples. I go through tons of these problems. So now that I have all these pieces, what I'm going to begin to do is I'm going to now sketch a little graph. All right? So just plot an axis. And what I'm going to do is I'm going to do this one at a time. So no x, I'll start with the x-intercepts, no x-intercept. I got my y-intercept of 0, 5. So that would be 1, 2, 3, 4, 5. Plot the point there. That's the y-intercept. Next, what I'm going to do is I'm going to just graph these vertical and horizontal asymptotes. So I got a vertical asymptote at negative 1. So what that means is I go to negative 1 and I draw my vertical line. And I'm just going to dash it just to make it look nice so it doesn't clash too much with the regular coordinate system. And then I have my horizontal asymptote at 0. So now this is going to lie exactly on that horizontal axis. So I'm going to leave it solid. Okay? I'm going to leave it solid for now. So now what's going to happen here is you have to now graph the function. So basically you have 4 quadrants, and it's broken up into the 4 quadrants based off of your asymptotes. Do not focus on the actual coordinate system. So either the graph is going to lie in this quadrant and this quadrant, or this quadrant and this quadrant, or this quadrant and this quadrant, blah, blah, blah. You know, any combination thereof. I already know I have a point in this quadrant, so I know that this graph is definitely going to be in this quadrant. I'll try to graph this line as best as possible. So it's going to look something like this, right, where it approaches those asymptotes over time. But what I don't know is I don't know where that other point is, right? Or I should say I don't know where the other graph should be. So what you're going to do is you're going to pick any point you want now. What I would suggest doing is picking an easy point, something that would, you know, maybe I'm going to pick a point of, let's say, -2 here for x, right? This would be -1, that would be -2. So if x is equal to -2, what I want to determine is what would the value of y be? Because then I can find a point, right? So what you do is you go to your function. Instead of x here, you plug in the value of -2. And then just do the math. So if -2 is plugged into here, right, that would be a -1. And then you're going to square it. And that's going to become a +1. Now that's the thing, right? No matter what you plug in down here, the denominator is always going to work out to be positive, okay? And therefore, you're going to have a positive value being divided by some positive value. There's no way that this function could ever obtain any value not in here. The y value always has to be positive, okay? So that's how we kind of figure that out. Let me draw that just a teeny bit nicer. I don't know how much nicer that is, but you get the idea. All right? And this is basically what the function should look like. Now, you can always check in your calculator. So go to your calculator and graph it. Do 5 divided by now. Open those parentheses. Do x plus 1. Don't forget to square it. Okay? And then hit graph. And look at that. That looks pretty darn close to what we have. Thanks so much for tuning in. I really do appreciate it. Check out our channel because we've got thousands of videos out there just for you to help you through your class. Not only in math here, but we got physics and chemistry as well. And the best way to do well on your exams is to do actual practice problems. Don't spend too much time studying those notes. You have to apply those notes to actual problems. Because what are you going to see on your test? Problems, right? Questions, okay? Related to applications. Check us out. Also, check out the description below. We're going to leave you a lot of goodies along the way. We'd love to help you. Talk to you soon.